dot points. Where possible, always cancel your fractions first. Okay, and that will mean that sometimes you'll have to factorize first to be able to do that, but always try to cancel out as much as possible first. If you are adding or subtracting fractions, then you must have a lowest common denominator to do that. Okay, and then you're able to add and subtract. Multiplying, however, you don't need that lowest common denominator. First of all, you will cancel as much as possible, and then you'll multiply the tops together and multiply the bottoms together. Dividing, Lachlan, haven't forgotten. Leave, kiss, flip, right? Okay, thanks Lachlan, I'm not going to forget that one. Okay, so when you're dividing, you leave the first fraction, you turn the divide into a times, which is the kiss, thanks Lachlan, and you flip the last fraction, dividing, okay? Then it becomes a times problem where you cancel everything out as much as possible, times the tops, times the bottoms. All right, that's it, that's fractions. So let's do it. They're going to increase in difficulty as we go. So in the first one, it just says cancel the following. It's just one fraction, so we're looking for something we can some factor there that we can cancel off. Always try to factorize first. When you've got two terms up here on the top, I can't just, don't ever do that and that, okay? It has to be able to come out of everything, which is why you always factorize first, okay? So on the top, I have a factor of 3 that can come out of both of those terms, leaving an a minus 3 inside the brackets over 9. Make sure your a's and 9s look different, okay? Then I can cancel the 3 that is out the front, okay? Only that one that's been brought out the front can be cancelled with the 1 on the bottom. So dividing by 3, that means that I would have a 3 here on the bottom. 9 divided by 3 is 3, okay? Next step is just to write down what is left. I have a minus 3 on the top. I no longer need those brackets because I've cancelled everything that was out the front. If you write the brackets, it's not a problem, but you don't need them. And the 3 is on the bottom. Okay, B. B. Same thing, just some more factorizing in there. So let's have a look. On the top, we have two terms. We have a minus sign there, and you have a squared there, so it could be tempting for some of you to think that that's like a difference of two squares, but we can't. All I can do is take out a common factor of that. I can't square root that a, not nicely anyway, the one on the end. So taking out a common factor, I can take out an a from both of them. That will leave me with a 2a from the first term, and when I divide the a by a, I will have a 1. Okay, so minus 1 there. The bottom, 4a squared minus 1. That is a typical difference of two squares. I can square root the first term and I can square root the 1. Okay, so straight away that goes to the double bracket. Square root of 4a squared, square root of 4 is 2, so 2a at the front of both brackets. Square root of 1 is 1, so that's the end of both brackets. 1 is a plus, 1 is a minus. Only when everything is factorized do we then cancel off. So I have a 2a minus 1 on the top and a 2a minus 1 on the bottom. You cancel off whole brackets. Write down what is left. A is on the top, 2a plus 1 is left on the bottom. Again, you can put the brackets around it still if you wanted to, but because it's on its own, it doesn't need it anymore. All right, question 2, stepping it up a little bit more. We're on to our adding and subtracting, which means we now need common denominators. Okay, so for the first one, the easiest way to get a common denominator is to multiply those two things together. 2a times 5 makes 10a. So 10a, I'm going to put it together straight away as one fraction. 10a is my denominator. Then I need to multiply, and a lot of you probably remember this multiplying diagonally thing. I multiply the 3 with the 5 on the bottom. So 3 times 5 is 15. The sign that I had was a minus sign, so put your minus sign in there. And then multiply the other way diagonally. 1 times 2a is 2a. Always check for simplifying, okay? Can I factorize this? Nah. Fifth, I can't bring a 2 out of it, I can't bring a 5, nothing's going to come out of those two terms, so I'm not going to be able to, I can't cancel the A because it's not a factor in both of them, so don't cancel, there's nothing you can cancel off there. The end, finish that one. Part B, same process again. First step, times 3 times 2 is 6 for the denominator. Multiplying diagonally, 2 times 2a is 4a for the first one. Then minus sign, a times 3 is 3a. This time, my things on the top, my numerator, they're like terms, so I can collect them up. 4a minus 3a is 1a, which we just write as a over 6.
Excuse the interruption, teachers. Can we have any new Year 8 or 9 students new to CCAS this year? If they can go to the IT department, any new students in Year 8 or 9, can you please go to the IT department? If you don't know where that is, the teacher will send someone with you to show you.
Alright. They'll send someone with them. Alright, keeping going. They're getting harder as we go. So now, they're all still the same. We need a common denominator. So 4 times 5 is 20. So 20 is my denominator. This is just going to get a little bit messier here because I need to multiply the m minus 3 with the 5. But I have to multiply all of that m minus 3 by the 5. So put it in brackets. Okay? Then this time I have a plus sign, so that's going to go next. And now I multiply the other way. I need to multiply the 4 with the m plus 7. There's 2 terms, or if there's 3 terms. When there's more than one term, put them in brackets to make sure that you expand them out properly. Okay, so that's my next step. Expanding. 5 times m is 5m. 5 times minus 3 is minus 15. Now the second bracket. 4 times m is 4m, and 4 times 7 is 28. Nothing to be done on the bottom, it's still a 20. Collecting up like terms on the top, we have 5m and 4m that will go together to make 9m. And minus 15 plus 28 is a positive 13 over 20. All right, D. Definitely the hardest type, yep.
Would you get in trouble with, like, lose marks if you skip writing the brackets and you just wrote it out expanded first?
No, if you did it, like if you went straight to this line,
Yeah.
is that what you did?
Yeah.
That you wouldn't, as long as you got it correct, okay? But just be careful, especially when there's minus signs here. Most people who try to expand things with minus signs without doing the brackets first will forget to expand that minus through. Happens so often, so just be really careful if you're going to try and take a shortcut, okay? All right, D. This one's more complicated because of those things. We now have the letters on the bottom, okay? But the process stays the same. The first thing that you do, going to need a big denominator here, is we multiply those two things together. 2w minus 1 and a w plus 3. We're just multiplying them together like we did before. Second step, multiply diagonally. The 3 times is with the w plus 3, so it's going to mean some brackets. 3 bracket w plus 3. Then I have a minus sign, so this is one to be extra careful. Now I multiply the other way. 7 times by the 2w take away 1. Okay? Go to the expanding step. 3 times w is 3w. 3 times 3 is 9. Now the minus sign. Be very careful here. Minus 7 times 2w is 14, minus 14w. Minus times a minus means that the next one's going to be a plus. 7 times 1 is 7. Don't expand the bottom. Okay, usually on the top we expand it because there's things that are going to collect up and we're going to be able to use it for something else. But expanding the bottom doesn't actually help us get anywhere else, so we don't ever expand the bottom. On the top, we're going to have 3w minus 14w, so that's minus 11w. And then we have a plus 9 and a plus 7, which is a positive 16. All over, and you just get sick of writing it, but we have to do it one more time. Our denominator, 2w minus 1 w plus 3. I know it's a pain to keep writing that denominator, but you can't just leave it out and then add it in the end. It has to stay there the whole way through the question. All right, any questions? All right, over the page. Question 3. Looks very similar, but there's a small difference here. We don't want to just multiply those denominators together straight away. And the reason why is because there's actually going to be a common factor that's going to be in both of them that's going to come out of this one. If I factorize that first, it will make it easier for me, okay? So first step is to factorize. So on the bottom, for that first one, I have a common factor of x, which will give me x bracket x minus 1. Okay, I can't factorize the top, so that's still 2 plus x. And the second fraction, I can't factorize the 5, and I can't factorize the x minus 1. So I'm just factorizing the denominator of that first fraction on my first line. Now by doing that, you can see that I have an x minus 1 that is a common factor in both of those denominators. So I don't want to have two lots of x minus 1 multiplied together in there. I'm making my denominator bigger than it needs to be. Okay, all I need to do is multiply this second fraction by an x, because this one has an x and that one doesn't, to make the denominators the same. Okay, so the first, my common denominator is going to be the x minus 1. The first fraction already has that denominator. Okay, so the first fraction, the numerator, doesn't need to change. 2 plus x, no change there. The second one, however, I have a minus 5 there, but that fraction, I have to multiply that by an x to have that denominator, don't I? So I have to multiply that minus 5 with an x. Okay, so it's going to become minus 5x. Okay, then I'm just looking to collect up like terms. So on the top, I have a 2, x minus 5x is minus 4x, and the bottom remains factorized, x bracket x minus 1. If you don't factorize first and you multiply everything together, you're going to find that you have a much bigger unsimplified fraction that's going to take a lot more work to try and factorize and cancel out at the end. So try to do that from the beginning where possible. Question 4. We're now up to multiplying. Multiplying actually should be easier, okay? It's not as much work. The thing is, you just want to be tidy when you're trying to cancel stuff out so you don't accidentally miss something. It's very easy to do. So you're just looking for anywhere on the top can cancel with anything anywhere on the bottom, okay? They can be directly above each other, above and below, or they can be diagonally. Anywhere on the top, anywhere on the bottom. So for example, what can I cancel here? I've got a 3 and a 9. Both of those can be divided by 3, which would give me a 1 here and a 3 there. I have also got some m's, one on the top, one on the bottom, so we can cancel completely away that m with that m. Once you've cancelled everything you can see to cancel, you multiply what is left. And all you do is multiply the top. So on the top, the numbers I have are 4 times 3, so that's 12. And the letters that's left, I only have a p left. Okay, so 12p. On the bottom, the only numbers that are left, I have a 1. So it's 1 times 7. So 7 is my number, and I have an n remaining. Always double check when you get to this stage to see if there's anything else that you missed in the cancelling process. Because if you miss something, you just do an extra line. You just go, oh, I could divide those numbers some more, and just keep simplifying if you missed it the first go around. Okay? Part B. As soon as we have 2 terms in a fraction like that, you want to look to factorize first, okay? Because that's going to be helping you to cancel things out. Okay, so for the first fraction on the top, I can factorize out a 5. That will give remaining a 1 minus 3m inside the bracket. The bottom, the denominator is just a 2. Nothing's going to happen with that, so let's leave that at 2. Second fraction, a 3 on the top. But on the bottom, with the 2 terms, I have a 1 minus 3m. There's no common factor, but it's exactly the same, 1 minus 3m, as the other bracket that I factorized, So they're going to cancel off. Okay, so that's why we factorize. All that whole bracket can cancel off. Looking at the numbers, there's no other numbers there that I can cancel, so we multiply what is left. On the top, 5 times 3 is 15, and on the bottom, 2, or it is 2 times 1 if you want to think of it that way, but there's just a 2 left on the bottom. Okay, an improper fraction is good. You can leave it like that. Also happy if you go to a mixed numeral. Either one is fine. Question 5, dividing. Lachlan, what do we do?
Oh, leave it.
Leave it?
I've got this. Leave it, kiss it.
Perfect. All right. So we leave the first fraction, 8xy over 5. We're going to kiss that divide and turn it into a times. Kisses, when you do hugs and kisses on your bed at the end of your letter. Kiss. And then we flip the second fraction, 5z over 3x. Again, make sure your z's don't look like a 2. Very easy, common mistake to not read your own handwriting right. And then I know, it looks a bit like a 2, doesn't it? How can I make that more like a z? All right. Smaller, sharper. A line, okay. Oh, that'll just make it messy. All right, so then it's just a times problem like the last ones. So now we're looking to cancel. I have an x on the top, x on the bottom. No, any numbers there? Yes, 5. 5 on the bottom, 5 on the top. I think that's it. So let's times. We're now doing timesing, so we times what's left. 5 is gone, so it's 8 on the top. And I also have a y and a z. On the bottom, the only thing left is that 3. So that's it. Part B, still a divide problem. So we leave, kiss, flip again. But because there is 2 terms, we're going to try and factorize as we go. Okay, so the first fraction, I can take a 2 out of that to get a minus 3 in the bracket. On the bottom, I can take out a 5 to get a minus 4. Am I going too fast with that? I'm assuming taking out a common factor is getting pretty easy. Good. All right, we're turning it into a times, and now we're going to flip the second one. Now, I can't factorize them, so I'm just turning them upside down. Okay? You can put them in brackets, though, if you like, because then you can identify which brackets can cancel off. So I have a minus 3, a minus 3, a minus 4, and a minus 4. And all that is left is a 2 on the top and a 5 on the bottom. Comes down to a very nice, neat answer. All right, question 6. Question 6a is all numerical, and the temptation would be to do that on your calculator, but don't. Okay, we are practicing our fraction skills. So for the first one, we want to simplify the top. We want to subtract those 2 fractions first, because doing that one divide line is basically putting them in brackets. Basically saying I need to group the top together, I need to group the bottom together. So I have to subtract the top 2 fractions and add the bottom 2 fractions before I can do the divide. Okay? So on the top, just looking at those top 2 fractions, 3 times 4 for my denominator is going to be a 12. Then multiplying diagonally, 4 times 1 is 4, and 1 times 3 is 3, so minus 3. Now to save myself some time, I'm not going to write as a fraction. I'm going to move it out the side and write a normal divide sign because I'm getting ready to do a flip. I'm going to flip that on the next line, okay? Then let's do our second set of fractions on the bottom. 2 times 6 is 12. Then diagonally, 6 times 1 is 6. 1 times 2 is 2. Now, just simplifying my numerators. 4 minus 3 is 1 over 12. Leaving. The divide turns into a time, so that's the kiss. And then we're going to flip, which is the 12 over 6 plus 2 is 8. Then we're multiplying, so we want to cancel I can cancel 12 and 12. Easy, easy. And all that's left is 1 over 8. Monty. Practicing that with numbers means that you should be fine to do it when there is letters in there. Okay, which is why you have to practice without your calculator. Because you can't do that one without your with your calculator. So, it may be easier to think of these as being over 1 here, so that you've got 2 fractions on the top, 2 fractions on the bottom. Just like the last question. So then we do the same process. The 2 top fractions, we're going to times the denominators together. A times 1 is A. Then we're going to multiply diagonally. 1 times 1 is 1. Minus sign, 1 times A is A. There's my first fraction. Like last time, I'm going to make it a divide out the side. Now for the bottom 2 fractions, same thing, we multiply our denominators together. A times 1 is A. Then we multiply diagonally. 1 times 1 is 1. 1 times A is A. Second step is to turn that into a times problem. So there's no factorizing that I can do there. You always got to check that first. So I'm going to leave the first fraction, turn it into a times, and flip. All right, looking for things that can cancel. A on the bottom, A on the top. I have left 1 minus A over 1 plus A. Can I cancel the A's?
Yes.
No. Those ones, yes. Those A's, no, I cannot. So don't fall for that. All right. There is your questions there for D. E and F aren't quite as big. Okay. All right, you're 11. Settle down. 1E, we're doing linear equations. So yes, done these many times. So you're just moving everything away. I know some of you still like to write your instructions. So doing the opposite is minus 4, which means that A is equal to 7. I prefer, however, at this level, you really need to try to not need to do that part anymore. You should be able just to move things without having to write those instructions anymore. Try. Year 11. No chatting, thanks. Remember, it's about speed. You need to be able to get through your tests in a certain amount of time. So the more time you can save while still showing you working out, the better. So B is a 2-step equation. First of all, we add the 4. So 2m, 11 plus 4 is 15. Dividing by 2, 15 divided by 2 doesn't go nicely, so you can leave it as an improper fraction or mixed numeral. Decimal is okay as long as it's an exact decimal. Don't ever go to a recurring decimal or a non-pattern decimal, okay? Part C, 2 steps again. So first of all, the denominator needs to go, so I need to times by 5. So x plus 4 equals 3 times 5 is 15, so there's a minus sign there as well, minus 15. Boys, can we stop having a chatter the whole way through this, please? Just listening. Tom? That means stop. Now minus the 4. So x equals minus 15 minus another 4 is minus 19. Part D, pronumerals on both sides. I always like to move the smaller one, which means I'm going to subtract the 3h. So 5h minus 3h is 2h plus 4 equals a minus 6. Then a normal 2-step equation from there. So I want to subtract 4. 2h equals minus 6 minus another 4 is minus 10. And lastly, to divide by 2, you get minus 5. Too fast, or is everyone keeping up?
Oh, no.
Good. If there is brackets, sometimes you can divide that away if it goes nicely, but this is not going to work for this one. So we're going to need to expand those brackets first. 3 times 4 is 12x. 3 times 5 is a plus 15 equals 7x. Again, I have pronumerals on both sides. I like to move the smaller one, so I'm going to subtract the 7x. 12 take away 7 is 5x plus 15. If I subtract that 7x, it means there's nothing left. There's 0 on that side. If you move it the other way because you don't want to have 0 there, it just means that you have more negatives to play with, but that's fine. It still works. Now I subtract my 15, so 5x equals minus 15, and dividing by 5 minus 3. Is everybody doing this style of working out? Yeah. Or you're still doing the little minus numbers or whatever in there as well? Okay. All right, fractions. If you have an equation where we have one fraction on one side of the equal sign and one fraction on the other side, then we can do what is called cross multiplying. It only works when there is one fraction on each side. If you get 2 fractions on one side and then a third one on the other side, then you have to go to another method, okay? But for this one fraction on either side, I cross multiply. So the 3 multiplies with the top of the first side, so 3 bracket 10 minus x equals in between, and then cross multiply the other way. 3 bracket x plus 1. Brackets, we're going to have to expand them out. So 3 times 10 is 30 minus 3x equals 2x plus 2. Pronumerals on both sides, minus 3 is actually smaller. So I'm going to add 3 to the other side. 30 equals 5x plus 2. Move the 2 away, so I'm actually working from the right-hand side at the moment. Minusing the 2 would give me 28 equals 5x. And then dividing by 5, you can either leave it as an improper or a mixed numeral. Calculator will do all that for you. Okay, question 2 is some practice rearranging equations that have both x's and y's in them. So y is the subject of these equations at the moment. That just means that y is the letter that's by itself. But we want to rearrange them to get x by itself, x the subject. So move everything away from the x. For the first one, that means subtract that 1 first. So y take away 1 equals 2x. And then I need to get rid of the 2, so I divide by 2. So I'm going to put the x on the left side, y minus 1 over 2. We always want our subject at the end to be on the left-hand side, which is why I switched sides. Part B is a little bit trickier because you have got 2 x's. It's pretty hard to get, or it can seem to be a little bit hard to get 1 x by itself when there's 2 of them. The thing is you have to collect them before you're going to be able to get the x by itself. So what you do, I'm going to get rid of the fraction first. I'm going to multiply that denominator across to the other side. So it's going to be y bracket x minus 1 equals x plus 3. Now I need to expand the bracket, so that's going to be xy minus y equals x plus 3. I need those x's together, so I'm going to move them to the same side. I'm going to leave the xy there. I'm going to move the one that's on the right-hand side, the x. I'm going to subtract it across to the other side like that. Now, I want those x's by themselves. So I'm going to move that other y away as well at the same time, okay? So I have a plus 3 that was already on the right. And this y here, I need to move it back to the right-hand side. Is that okay? I know I'm doing a few steps there at the same time. Okay, so my x's are together, but I need to factorize them out, so there's only one of them. So factorize the x. X bracket y minus 1 equals 3 plus y, or y plus 3. Now there's only one x. All I have to do to get it by itself is to divide that bracket across to the other side. So x by itself equals 3 plus y over y minus 1. Fun, hey? All right, 1 to go. And then hopefully we'll get most of our second period to get lots of work done. All right, last thing for today is solving quadratic equations. Guys, the chatting slows us down. So we factorized quadratics yesterday, but this is the extra step where you have to solve. There is different ways that you can solve quadratic equations. Your first thing that you should try is to try and factorize things. Unless it tells you otherwise, you should always look at it and see if you can factorize it. Okay? We also have completing the square method, which we're going to learn about not today. We're going to skip that one today. And we have the quadratic formula. You learnt all these last year. Quick recap. Okay, so we're doing factorizing and the quadratic formula today. So the first one, example number 1, solving by factorizing. So we have 3 terms, and it equals 0, but 3 terms in that quadratic there, which means we need to put that into 2 sets of brackets. However, there is a 5 in front of that x squared, which means it's the slightly harder type where we have to split it into 4 terms. So remember yesterday, I drew some lines there where I went, we have to multiply the 5, whoops, not with the highlighter. We need to multiply the 5 with the minus 7, which is minus 35. So I'm looking for 2 numbers that times to give minus 35 and add to give a positive 34. Okay, they're pretty close together. What are they going to be?
35.
Correct. So those 2 numbers, the 35 and the minus 1, is you're splitting that middle term. So the first term stays the same, 5x squared. Instead of that 34, we're splitting it to be a 35x and a minus 1x, which is just minus x. And the last term, the minus 7, also stays the same. Now we have 4 terms, which means we factorize in pairs. So taking the first 2, I can factorize a 5 and an x, which will give me x plus 7. Then the second 2, the third and the fourth, the only thing I can bring out of those is a minus sign. So bring out the minus, x plus 7. Those brackets must be the same for this to work, and they are. So now we can factorize our last step. The x plus 7 is my common factor. The 5x and the minus 1, so this here, if there's no number there, remember that's a minus 1. I have to put a 1 in there. Okay? 5x minus 1 in the second bracket. Don't forget the equals 0. This is an equation. You have to write that equals 0 the whole way down. So what I just did there is exactly what we did yesterday, just with the equals 0 on the end. The only extra part today is to do the solving part at the end. What is x going to be equal to? This is the Null Factor Law. Remember this? So each one of those brackets could be equal to 0. So some of you are very comfortable going straight to the solution, especially if it's just x plus 7. What's it going to be? So x equals minus 7. You just change the sign. However, once you start getting these ones with a number in front of your x, for some of you, it's definitely beneficial to do that extra step where you go, first of all, 5x minus 1 equals 0, which means 5x equals 1, x is equal to 1/5. Okay, do that rearrangement so you don't get confused. So that bracket is equal to 0, and then you're just moving everything away from the x. Okay, so there are your 2 solutions. Quadratics usually have 2 solutions, okay? Unless the only other conditions is if they are the same solution. So it's x minus 1 in brackets squared, then it comes out as 1. All right, question 2, solving by using the quadratic formula. Can you remember the quadratic formula? Anyone want to have a go? Yeah, Monty, go. Oh, sorry.
Is it plus or minus b?
There is that, not yet. Jess.
Minus b plus or minus the square root of
B squared plus A.
B squared.
minus
Over 2.
All right, good. I'm glad that you kind of remember. All right, I have some good news for you. In your HSC, they give you this. This is your formula sheet, okay? Now, not everything is on here, so not every formula that we do over the next 2 years is going to be on here, but some of them are. The quadratic formula is on there, okay? So when you do a test, I am going to always give you a copy of this to use when you do your tests, okay? Because you have in the HSC, so you might as well use it for your tests as well. Okay, now if you want to have your own copy of this, I have added that as a resource on Sector. So you know where you get your textbook from? You just look down a bit and it also says, I think it's 2019 formula sheet, because it's been the same since 2019. You can just download yourself a copy from there, all right? And you can have that saved to your computer so you know what's on there. All right, so to use this formula, the A, the B, and the C. A is in front of the x squared, B is in front of the x, and the C is the number on the end. Notice I said number in front of. Don't ever sub the x's in, okay? It's the numbers that we want. All right, so it's a formula we just sub in. B is 34, so I'm going to have minus 34 plus or minus, big square root sign. B again, so it's going to be 34 squared. If B is a negative number, please put that in brackets when you square it. Big common mistake that a lot of people made last year was to put, say, minus 5 squared in their calculator, and their calculator tells you minus 25 because it doesn't square the minus unless it's in a bracket. Okay, so if it's a minus number, put it in brackets before you square it. Then minus 4 times A, which is 5, and C, which is minus 7, over 2A, and A is 5, so 2 times 5. Now this question hasn't specified how to leave the answer, exact or decimal, so I'm going to work down and do it exactly, because it comes out quite nicely, this one. It's alright, we're nearly done. And we have a double. Alright, so the minus 34 plus or minus, first of all, you just want to work out what is underneath that square root sign. Okay, so you just type in 34 squared minus 4 times 5 times minus 7. Type it in. It's a good thing to check as we go through. And you should get 1,296, correct? 2 times 5 is 10. Now, if this is going to work out nicely, I should be able to square root that number. What is, or try in your calculator, what is the square root of 1,296? 36. Look at that. Okay, so to get your two solutions out of this, you need to type each one separately. You can't do a plus and a minus together, Ashton. So, you're going to type in minus 34 plus 36 all over 10. So make sure those two numbers are together on the top of the fraction, over 10. So that's 2 over 10, which simplifies to 1/5. Calculators will do it all for you. Then you want to do the second one, that's an OR, minus 34 minus 36 over 10. You can just use your calculator, use the back arrow, change a plus to a minus sign. And that comes out as minus 7.